Now the time has come to talk about one of the big algebraic fundamentals you'll need to review, and that is solving equations. Various types of equations: linear equations, quadratic equations, rational equations, radicals, absolute values, all sorts of that we're going to review in this section. Linear equations are the easier type to solve. Your goal is to get x isolated to one side of the equation to solve. So you look at an equation like this, and the reason it's linear is because x is just raised to the first power. So you'll want to balance the equation by getting maybe all the x terms to the left side and all the constant terms to the right by using addition and subtraction. So for example, just subtract the 10x from both sides. So that way the 10x cancels here, and that gives you negative 6x minus 19 equals 11. So you do have all the x terms on the left. Now you're going to get the constant terms over here on the right. So you balance that out by adding the 19 to both sides. And that leaves that cancels the 19s out here, leaves you with negative 6x on the left equals 30 on the right. And now you're almost done solving for x. Now that you've taken care of the addition and subtraction to get the x on one side, the constants on the other, now you want to divide both sides by negative 6, and that will completely get the x by itself to get rid of that negative 6 coefficient. So your final answer comes from dividing positive 30 by negative 6 to get a solution of x equals negative 5. Now, part of the equation solving process is also to double check and make sure you got the solution correct. So remember, the original equation said 4x minus 19 equals 10x plus 11. So if you were to take the original equation and actually plug negative 5 in for the x's that you see here, you should get a true statement. You should get the left-hand side and the right-hand side are equal to each other. So if you replace negative 5 for both of those x's, we will see if we get a true statement. So let me put a question mark up above the equal sign to see if this does generate an equality. The left-hand side is going to become negative 20 minus 19. Negative 20 minus 19 gives you negative 39 on the left. And if you simplify the right-hand side, you get negative 50 plus 11. And if you take negative 50 with positive 11, that takes the negative 50 to a negative 39 as well. So since the left-hand side equals the right-hand side, that means the solution checks out. I mean, you can do this on paper or you can double check it on your calculator, but most any equation you solve, you should develop some means of checking the solution to see if you're getting it right. Okay. Another example of a linear equation is something as simple as just solving a formula for a variable. So there are 4 variables mentioned in this formula. There's a capital A, a capital B, a lowercase x, and a capital D. And you're asked to solve this formula for x. So that means the other variables, the A, the B, and the D, will be left in the answer after you've solved for x. So what you want to do is try to simplify the equation before you actually go through the solving process. See, there's some nested parentheses here, and you could probably eliminate those by using the distributive property. So maybe go with the innermost set, and there's a 5 that you can distribute here to transform the equation into a minus 2 times bracket b plus 5x plus 30, and then equals d. Now within here you've got you don't have any like terms you can simplify in the brackets, but now you've got a negative 2 that you can distribute to help get rid of that last set of grouping symbols. So if I take care of that, negative 2 distributes here to give me a minus 2b minus 10x minus 60 equals d. And we're at least have gotten rid of all the grouping symbols. So we can see that it is a linear equation involving x. X is only raised to the first power, and we can get x by itself by bringing all these other quantities over to the right-hand side. So to start that process, I will subtract a from both sides. I will add 2b to both sides, and I will also add 60 to both sides. And that step will get the x term isolated on the left by itself. You'll be left with negative 10x on the left. Now, notice over here on the right-hand side, the positive d that was already there, you have to subtract all these other terms from it because they are not like terms. Okay, so it's just going to be a variable expression like this, since you can't really collect any of those together. But your final step is to divide both sides by negative 10. And so you can state your solution is x equals d minus a plus 2b plus 60, all divided by negative 10. And that is a sufficient answer in my opinion. Just be careful. Again, these four quantities up top are terms that are using addition and subtraction, so none of those can cancel with that 10. You may be tempted to try to divide the 60 by the negative 10, but they can't cancel because this 60 is not a factor in the numerator. It is a term. Terms cannot cancel with factors, so you can leave the answer like this, and that's a sufficient solution for solving that formula for the variable x. Okay. So linear equations are the easier types of equations to solve because you just have x to the first power, and it involves what we did in these two examples, getting x to one side, the constants or the other terms to the other, and then your last step is usually dividing to get the x isolated and solve for. Okay. Now, second category of equations that are of interest are the ones you'll probably encounter most frequently, quadratic equations. Quadratic equations come up in every math class that you're going to take between here and even going as high as differential equations. Differential equations and calculus 3, yeah, that's like every calculus class uses a quadratic formula or a quadratic equation at some point or another. So it's worth reviewing how they can be solved. Quadratic equations take this generic format: ax squared plus bx plus c equals 0. If it's a quadratic equation, what makes it quadratic is that squared power right there. So the name quadratic indicates that you will have a squared variable x involved. Now, there's a big battery. There's a lot of different types of ways to solve a quadratic equation. You can solve some of them by factoring. Factoring works some of the time. It requires you to be able to actually factor the polynomial that's used in the equation. Square roots come about whenever you have a single x squared or a squared quantity, so you can just isolate the x squared and solve by using a plus or minus square root. Completing the square actually works every single time, but and I mean it's a pretty quick algorithm to use, but most people who use completing the square eventually use the stylized version of it with the quadratic formula, because those are effectively the same way. The quadratic formula exists because someone has completed the square on this generic quadratic equation to get to a solution for the x values. So let's roster through some of these techniques of solving quadratic equations as part of our review. This one you're asked to solve by factoring. So you got the advantage in the problem to let you know that whatever this turns into when I get it in this form, it should be factorable. Now, in order to solve by factoring, you have to make sure it's in this form first. It has to be all the x squared, the x, and the constant term on the left-hand side set equal to 0 on the right-hand side before factoring even makes sense. So there's some cleaning we need to do here before we actually get into that format. The left-hand side, you can distribute to where it's going to be 6x squared minus 6x. The right-hand side has a 21 minus x. So in order for me to get it into that standard form, I've already got the x squared on the left, the 6x squared here. I'll bring these other two terms from the right over to the left by adding the x, and that'll combine with the negative 6x that's already over here. And I'll also want to subtract the 21 and possibly wedge it right there between the before the equal sign. So that way the right-hand side does fully become 0 like you want it to in this standard format. The left-hand side now becomes 6x squared, negative 6x and 1x is minus 5x, and then minus 21 is my constant term. Okay, so if this is factorable, I should be able to factor it using, whatever factoring methods I can. There's no greatest common factor I can take out because of the 5, but I can go to the AC method and see what my factors look like. A times C is going to be 6 times negative 21, which is going to be, let's see, 126, negative 126. And so now I need to find two factors of negative 126 that add up to a negative 5. So let's see. We've got, there's going to be several probably. Positive 1 and negative 126. Those don't add up to negative 5. You've got positive 2 and negative 64. You've got, let's see, will 3 work? Yeah, 3 goes into it. Positive 3, and let's see, 3 goes into there 42 times, so negative 42. Still not getting to that negative 5 yet, but keep on searching. You're bound to find it eventually if it's factorable. Let's see, the last 2 digits are not divisible by 4, so I can't use 4. 5 won't work. I can try 6. 6 goes into it 21 times, so 6 and negative 21 are a pair. So we're getting closer. And let's see, 7 won't work. 8, does 8 go into it? Well, 4 didn't go into it. 8 would be, no, 8 won't work. 9 will work, so let's try 9. 9 goes into it, let's see, once, 14 times. Oh, boom, there we go. Positive 9 and negative 14 add up to negative 5. So that means our factors come from 9, positive 9 divided by 6, and negative 14 divided by 6. And those reduce to plus 3 halves, and this reduces to minus 7 thirds. So remember, these fractions tell you the binomials. The binomials for your factors are going to be 2x plus 3, and the other binomial factor will be 3x minus 7. And let's double check it really quick to make sure that that factored correctly. I mean, I went through the AC method pretty straightforwardly, and it gave me the correct answer. I think it did. Well, let's check it to make sure. That's going to be 6x squared. That checks out with the first term. The O in FOIL is negative 14x. The I in FOIL is positive 9x. There's the negative 14 and the positive 9 that add up to negative 5x. That checks out with the O and the I in FOIL. And last times last is negative 21. So I'm all confident that that is factored correctly. So now, to use factoring to solve an equation, since these are set equal to 0, anytime something is multiplied or factored and set to 0, you can actually set the individual factors themselves equal to 0 to get your full solutions to the quadratic equation you're solving. So, when I solve this out, this is going to solve for x. Subtract 3 from both sides. 2x equals negative 3, and then divide both sides by 2. You get x equals negative 3 halves. And then the other solution, add 7 to both sides. 3x equals 7. Divide both sides by 3. X equals 7 thirds. So, one of the handy things about using the AC method is your actual solutions turn out to be the opposites of the two numbers you found that gave you your factors. It's kind of an interesting little coincidence that does work every time if you want to take advantage of it. Okay, so let me pause this video. You've got a lot to take in, and we'll resume with the second group of equations to solve for quadratics by using square roots. Okay.